Hi, my name is Elisa Sotelo, and this is my video explanation of the circuit. So the problem consisted on building a photovoltaic system and measuring its electrical behavior with different lighting conditions. We obtained the current and the voltage, and also we had to measure the different data during the day and the night and compare the theoretical calculations with experimental measurements. So we did this by placing our module perpendicular to the sun to obtain the short circuit current and the open circuit voltage. And with a potentiometer, used we used it to measure the current and the voltage to get the characteristic curves and the maximum power point. These were some of the measurements that we got when we had sunlight. We measured the voltage and the resistance, and then we used the formulas called Kirchhoff's law to get the current. We did the same measurements with shade and artificial light. With those measurements, we were able to get this graph, which is the voltage power characteristic curve, and it shows that the highest power point is when the voltage is equal to 3 volts and the current is equal to 6.5 amperes. And with the formula to get power, which is power equals current times voltage, we found that the maximum power point was 19.5 watts. Now this is our electrical circuit, and in the left we have the model using Tinkercad, and in the right we have the real circuit. Um, this is how it worked during the night. The LED was supposed um to be on, and during the day it was supposed to be off. We made this model of the circuit during the night, and we had these three meshes. We made the analysis with the mesh analysis method, and the data we used was that the solar cell, which is represented by V1, equals 6 volts. Our battery, which is represented with V2, equals 3.7 volts. And our diode, which is represented by V3, equals 0.3. Our resistance is 100. Well, resistance 1 is equal to 100 ohms, and resistance 2 is equal to 10k ohms. We got those results. Current 1 is equal to 0.04. Current 2 is equal to negative 0.012, and current 3 is equal to 0.012 as well. This was our model of the circuit during the night, and we used the same method, mesh analysis, to get the currents. We used the same data, and we got the results of current 1 is equal to 0.03 and current 2 is equal to 0.57. Now, so using the data that we got, we we were able to calculate the theoretic voltage of the resistances, and we compared them to the experimental voltage that we had obtained during the measurements. And we can see that, well, it's important to measure to mention that the experimental voltage data we used to compare our analysis was the one we gathered from our measurements with sunlight, because that's when the solar cell had around 6 volts, which is the voltage we used in our analysis. And now what we found is that, well, we can see that there is a very significant difference between the experimental and theoretical measurements, and this could be due to problems during the experimental measurements, because we did have issues with the multimeter when trying to measure the different values. And another possible explanation could be that something wasn't connected correctly in our circuit, uh, because we did have issues with the material. For example, some LEDs burning down, and we had to change them a couple times. So my final conclusion from this project is that we successfully met the objective of constructing a photovoltaic model through experimental measurements, and the project provided valuable practical experience in applying Kirchhoff's laws to calculate electrical variables, and it highlighted the critical challenges in accurately predicting the performance of photovoltaic systems under real-world conditions. And that's all. Thank you.